Welcome back to another video. In this tutorial, we are going to look at how we can understand the concept behind scalars and scalar dot product. So we begin by scalars, then we look at what scalar dot product is. Okay, scalars, and then we follow up with scalars or dot product. Okay, so what are scalars? Ask yourself, what is a scalar? Now, a scalar is a quantity that has a magnitude but no direction. So that is basically a scalar. You can define it in your own way. This is grammar. Okay, so the key word has to be, it has no direction, but it has magnitude, or it has magnitude and it has no direction. Then you can think of something like when you talk about scalars, then you can begin to think about something like temperature. You can begin to think about something like length. You can begin to think about something like time. You know, time does not have direction, but it has magnitude. Temperature does not have direction, but it has magnitude. Okay, so those things are what we quantify as scalars. We have so many examples that we can give. Okay, so let's look at what you understand what scalars are. Let me brief it up. Scalars are quantities that have magnitude but have no direction. Okay, so you know this. Now, begin to think of something like temperature. You know, the temperature that you go and check at the hospital. You can't determine its direction, but it has magnitude. Okay, you can think of time. Your time, your clock, it has no direction, but it has magnitude. Okay, so these things and many others you can think of when you talk about scalars. Okay, so let's look at dot product or scalar or dot product basically. Okay, so sometimes people call it scalar product, and sometimes others do call it dot product, but I love to call it scalar product because it's quite simple than call it dot product. Okay, wait, you call it any way you like, they're all good. Now, what are dot product? So dot product is just a scalar or a scalar product, right? So it's a scalar product of two vectors, okay, of two vectors that, let's say, vector a1 and vector a2. Okay, that has an angle between them. So it has, let's say, vector a1 and vector a2. Okay, and these vectors are denoted as a1 dot a2. Okay, so that is what we call scalar product. So a1 dot a2, the magnitude of these vectors, okay, the magnitude of these vectors, okay, they have some common angle, these vectors, okay, and the angle between them is called theta. It's called theta. So dot product or scalar product is equal to a1 dot a2 equals the magnitude of these two vectors times cos theta. Cos theta. So cos theta or theta is the angle between them when we talk about scalar product. When we talk about scalar product. So let's look at some common properties that you have to know under scalar product or dot product. So the first property is A dot B is equal to B dot A. That is the first property you have to know. It's very important. Okay. So once you know this property, also note that A dot into B plus C is equal to, this is what property, this is distributive under scalar product, because you can distribute A to all the items in the bracket. So we can have AB plus AC. Okay, so that is the second property. The third property is when you're having a scalar times vectors. So when you have a scalar multiplying scalar product. Okay, so this is scalar product, and this is basically the same as, associativity property. You can exchange the positions, right? So this, you can rewrite this as MA dot B. So this is the third property. The fourth property, okay, so these are basically the main properties that you have to know. So as I said, this is a scalar. The M is just a scalar. Okay. Now, you know that I dot I is equal to, can you tell me? I dot I is equal to J dot J. And that is equal to K dot K. Okay. And you know that it should be giving you 1. So I dot I is equal to J dot J, and that is equal to K dot K. That should give you a result of 1. That is a property that you have to know. Likewise, you know about the unit vectors. So I dot J dot J, K dot K is equal to 1. Okay, the next one is I dot J, okay, I dot J is equal to J dot K, and that is equal to K dot I. So that is equal to 0. So when you combine two opposite position vectors and you find their dot product, it should be giving you 0. But when you look at same position vectors and you multiply them, it should be giving you 1. Okay, so that is basically for the properties. So now these ones, I can talk about the proofs. Okay, so you can talk about the proofs in here. The I dot I, the J dot J, the K dot K equals 1. You can talk about the proofs by using cos theta and the magnitude stuff. Okay, so let's talk about the proof. So the proof of the first one, okay, we know that I dot I is equal to the magnitude of I times the magnitude of I times cos theta. Okay, and theta here is 90, right? Cos 90, right? Okay, so since they have same position vectors, okay, same position vectors, then we're going to have cos 0. So cos 0 here. So once you have same position vectors and you are taking their dot product, then the angle between them should be equal to 0. So you know that cos 0 is 1, and you know that unit vectors, right? Unit vectors are equal to 1. So 1 times 1 times 1 times 1, right? So we have I dot I equals 1. So that is what we have proven here for the first part. So basically it runs through for the J dot J, K dot K. So the same thing for the J dot J. So that is equal to the magnitude of j times the magnitude of j cos 0. So that is equal to 1 times 1 times 1. That is equal to 1. Okay, the same thing applies to the k dot k. So that is also the same process, cos 0, and that is 1 times 1 times 1. That's also 1. When it comes to the opposite position vectors, then you can begin to think of being perpendicular. So they are moving in the perpendicular direction because you have something like this, right? And you have I here, you have J here. So meaning the angle between them is 90, right? So when you take the dot product, you're going to have 0. So I dot J is equal to the magnitude of I times the magnitude of J cos 90. So that is basically equal to 1. You know that the magnitude of a unit vector is 1. So we have 1 times 1 times 0, and that is basically equal to 0. So that is basically the proof. Okay, so it runs true for all. It runs true for all. So that is how it goes. I know you are loving the lesson, right? Good. So now let's look at some few other properties. Okay, some few other properties. Then we can begin to solve problems. Okay, so this is property E. This is going to be F. Okay, so property F is if, for instance, you have A, okay, A equals some position vectors, okay? So say A1 I plus A2 J plus A3 K, okay? Then, and you're having another vector, say B, okay? B1 I, B2 J plus B3. So it means that A dot A is equal to A squared. Then you can have A1 squared I plus A2 squared J plus A3 squared J. The same thing applies to the B. Okay, so the next property for us to start handling problems, okay, is to make the lesson so interactive. We will solve problems to make the lesson interactive. So the last property, which is J, is, for instance, if you have A dot B, you know that A dot B should be giving you 0, right? Right? So for a particular or orthogonal, right? So then you can say that A and B are orthogonal or perpendicular vectors, right? So A dot B equals 0 if A and B are not null vectors, right? Null vectors meaning that if they are not null vectors, it means they have some common features, right? They have some common intersection. So if it happens that, then you can say that A and B are orthogonal. Okay, so if they are orthogonal, then it means the dot product of these two vectors must be giving you 0. Interesting. So now let's start with some problems. So problem 1, we want to find the angle between the vectors A equals this and B equals that. Interesting. So here we have learned about scalar products. We know what dot product is, and we want to find an angle, the angle between these two vectors. Now, we know the formula, right? We know that the dot products, right, of two vectors is equal to the magnitude of the two vectors times the angle between them. So the angle between them is what we are interested in here. Okay, so here we have to find the dot product of the two vectors and we have to find the magnitude of the two vectors. Then we can go ahead and determine the angle between the two vectors. Now, let's begin. So A dot B will be equal to, we have A here to be 6i minus 3j plus k, and B to be 2i plus 2j minus k, right? So here we can say that 6 times 2 is 12, minus 3 times 2 is minus 6, then 1 times minus 1 becomes negative 1. So we have A dot B equals 12 minus 6 becomes 6 minus 1, right? And that is basically 5, right? So we have A dot B to be equal to 5, right? Now, what we needed next, we have to find the magnitude of each vector. So magnitude of A will be equal to 6 squared plus negative 3 squared plus positive 1 squared. And that is basically equal to square root of 6 squared. That is 36 plus 9 plus 1, right? So we have magnitude of A to be equal to square root of 36 plus 1 is 37. 37 plus 9. 37 plus 9 is basically 46, right? So we have 46 here. Okay, so the magnitude of A is basically 46. So once we have the magnitude of A to be 46, we go ahead to find the magnitude of B. So here we have magnitude of B to be equal to, vector for B is 2i, so we're going to have 2 squared plus 2j, that is 2 squared, plus negative 1 squared, right? So we have magnitude of B equals 4 plus 1. So we have square root of 9, and that is equal to 3. So the magnitude of B is equal to 3. Wow. The game is getting interesting. The game is getting interesting. So we have magnitude of A, magnitude of B. So we can see that magnitude of A times magnitude of B is equal to 3 times square root of 46, right? So we have this here. This is what we have. We know the formula. Now we have A dot B. We have the product of the two magnitudes. So now we can easily obtain our theta, right? So we have A dot B is equal to magnitude of B times magnitude of A cos theta, right? So here we have A dot B to be 5, and we have magnitude of A times magnitude of B to be 3 root of 46 cos theta, right? So we're going to have cos theta equals 5 over square root 5 over 3 times square root of 46, right? So here we can say that our theta is equal to cos inverse of 5 over 3 times square root of 46, right? So this here, guess what? When you verify this very well with your calculator, you know that you are going to have 75.77. So we have our theta to be equal to 75.77 degrees. So we can say that the angle the angle between vector A and B is 75.77 degrees. Wow. So that is the end of the problem. So if you have two vectors and you want to find the angle between them, then quickly you have to remember that A dot B is equal to the product of the two, the magnitude of the two vectors cos theta, right? So you find the A dot B and then you find the product of the two, the vectors, the magnitude of each of the vectors, okay? Then you can go ahead and do substitution, do change of subject, then find your theta. So right here, to this question, we have our theta to be 75.77 degrees, and that is the angle between the two vectors. Okay, so let's look at example 2 where we have our theta and we want to find the dot product. Case, in this problem, we have been given the two vectors and we have been given the angle between them, and we want to find a certain missing variable. Okay, so we have to do change of subjects and find our variable. Here our variable is p. Okay, so we know that a dot b is equal to magnitude of a times magnitude of b cos theta, right? So here we find the a dot b. So a dot b will be equal to, our a is 2i plus j minus 2k, right? And our b is 2i plus pj minus 4k, right? So here we can say that a dot b is equal to 2 times 2, that is 4. 1 times p becomes plus p, and then minus 2 times minus 4 becomes plus 8, right? So we can say that our a dot b is equal to 4 plus 8 becomes 12 plus p, right? So we have our a dot b in terms of p. Okay, let's find the magnitude of a, right? So the magnitude of a will be equal to 2 squared plus 1 squared plus 2 squared, right? So we're going to have the magnitude of a to be equal to 8 plus 1, that is square root of 9, basically 3. Magnitude of b will be equal to 2 squared plus 1 p squared plus 4 squared, right? And that is equal to 4 plus p squared plus 16, right? So we have the magnitude of b to be equal to 4 plus 16, and that is 20 plus p squared. 20 plus p squared, right? So we have the magnitude of a, we have the magnitude of b, right? So here, when we multiply the magnitude of a and the magnitude of b, then we are going to have 3 square root of 20 plus p squared, right? Now, we have been given theta, right? Theta to be equal to cos inverse of 1 on 3. Great. So this means that when we want to find cos theta, then we have to multiply both sides by cos, right? So cos here, we're going to have cos theta equals cos here times cos inverse of 1 on 3, right? So this takes off this, right? So we have cos theta equals 1 on 3. So we have our cos theta to be 1 on 3. Now let's go to our formula. we have A dot B is equal to magnitude of A times magnitude of B cos theta. We know cos theta to be 1 on 3. We know A dot B, we know the product of their magnitude, right? So now we're going to do our substitution. At this point, we can say that P plus 4 is equal to 3 square root of 20 plus P squared all over 3, right? So over here, we do cross multiplication. So we're going to have 3 into P plus 4 equals 3 into P plus 4 equals square root of P squared right here. Okay. So this is what we have. Okay, so what can we do here? What can we do? So here we can say that these 3 divides here. So we have P plus 4 equals square root of 20 plus P squared, right? Now we are interested in the P, right? But because of this square root sign, we square both sides, square here. So we're going to have P squared plus 2 times this is going to be 8P plus 4 squared is 16 equals 20 plus P squared, right? So here, this P squared comes here and it goes off, right? And we're going to have 8P plus 16 equals 20, right? So this goes here. So we have 8P equals 20 minus 16. So we have 8P equals 20 minus 16 is 4. So basically, we are going to have our P to be equal to 4 on 8. So 4 on 8 is basically 2 here, 4 here, then 1 here, 2 here. So we have our P to be half. So the value of P is basically half, 1 on 2. So therefore, or thus, the value of P is 1/2. The value of P is 1/2. Ladies and gentlemen, I really appreciate your time. Don't forget to subscribe, share with your mates, and I'm going to give you more updates. Bye-bye.